Hello everyone, today I am going to deliver a lecture on, first of all I will try to deliver a lecture on determine the size of combined and met foundation, and it can also include, and we can try to find the thickness of the foundation also. So, and second one in determine the pressure of combined and met foundation, size and size and thickness of combined and met foundation. Okay, so let's start. Here is an example we can see. It is taken from BNS Murthy page 602. Okay, so before going to perform the lecture, I want to showing the example. So let's read the question first. The the question is the end of column is along the property line. Here is a column we can see here, and this is the property line, and is combined footing and interior column by trapezoidal footing. This is the trapezoidal combined footing. The figure is given below. The following data are given. Column Q1 is given 2016 is given here, and Q2 5660 is 560, and size of columns 0.46 into 0.46 inch square, and LC is a clear length of distance between column, which is 5.4 meter, and determine the dimension A means this dimension A, and B this the right dimension of B of trapezoidal footing, and allowable bearing capacity is given 19 kilopascal. So these data are given Q1 Q2 C1 C2 and a clear length and bearing capacity. So we have to find out A and B. So let's see. So we can know the summation of Fy equal to Ry, Q1 equal plus Q2. Here is a Q1 and Q2 equal to Ry equal to resisting force. So downward force equal to upward force. So upward is Ry is 1357. So we are taking moment M force equal to M resisting. So Q1, this is the Q1, and C1 divided by 2. This is the distance. This we can see here Q C1. So distance is column divided by 2. Column is 0.46. So 0.46 divided by 2, and Q2. This is the Q2. So the Q2 distance will be C1 plus 2. This is the C1 plus 2 plus LC. This is the LC. I'm erasing now. This is the LC. And going to the this CG, the column CG of 2. This is the Q2. Plus Ry is a resisting wave found here, and XR we will found the resisting distance, and we have found the resistance distance 2.62. This is the resistance distance XR 2.62. So now we know the stress equal to force per area. So stress equal to Q, and we are substitution this, and area equal to Q by net, area Q by stress, force per stress. So force equal to Q1 plus Q2. We know Q1 and Q2, and stress equal to allowable bearing capacity is given. So which is found 18.62. Now area of trapezoidal footing, area equal to we know the stress into footing, and on the other hand half into A plus B. A means this and this. A plus B divided by 2 into L, and A plus B is found. L is nothing but this is the LC plus C1 plus 2 plus C2 plus 2, or C1 plus 2 L plus LC plus C2 plus 2, and this way and found the A plus B equal to 6.34, and A equal to is here, and B is getting in the right side, and this is the equation 6.34 minus B. Now we'll see L equal to C by 2. This is the LC. L equal to will be C1 plus 2 LC plus C2 plus 2, and we are calculating this and found 5.94. And x1 is nothing but this is the three section I have divided in 1 2 3. So x1 equal to this value divided by 2. So we can see 5.94 divided by 2. And x2 is nothing but this is from x2, so 1/3 into L, so we know 1/3, and L is 5.94 and 2.62. Now we will go to the taking the moment and the moment of force and resisting moment. So now we are calculating the three portion. So this is the three portion I have segmented here. So 1 2 3, and 2 3 are same. So A1 x1, so we know A1 x1, so A1 we know 5.93 into B, so 5.994, which is the length. So we know that this length, total length, or we can say total length. And B is unknown, this is the B. So this portion 1 is gone into x bar, x1 into total length LC, not LC, it will be L, this is the L, divided by 2. So this is the portion of A1 x1. So A2 x2 will be this portion, which is half into length is known, 5.94, and height equal to this side. So I will calculate this side. So we know this is the total A, this is the total A, and this is the A by 2, and this is the half of A. And if we deduct this means is B. So B divided by 2, it will be B divided by 2. So if we subtract from A by 2 minus B by 2, then we will found this portion, length of this portion. Okay, so in this way we have found A by 2 minus B by 2, and XR will be 1/3 into 5.93, so 1/3 equal to 5.94 into 2. Why we will multiply by 2? Because this is the 2 portion, A1 and A2 A3 are remain same, A2 and A3 remain same, that's why we multiply 2. AT is the trapezoidal area, so we know all the trapezoidal area A plus B into 2 into 5.94 is the length, and 2.6, and in this way calculating we have found B equal to 2.04. So we are putting this B value here and found A equal to 4.63. This is our answer, A equal to 24 and B equal to 4.33 inch. So if we need to know extra knowledge, so if we want to find out the thickness of the mat of the footing, that's we have to calculate here. So now I'm zooming here. So area AP, area of perimeter, C1 plus D by 2 into 2. So this is the footing. So we are calculating here. So this is the C1 plus D by 2. This is the D by 2 into 2, because this is the 2 portion. This is the 2 portion. This side and this side, and D by 2 plus C. This is the D plus C, and this is the C, and this is the D plus 2, and into D. So these are there is no portion, and into D, and found this equation. And the B perimeter, B punching will 0.85.34 FMC AP is found from previous calculation, and found this equation. And the AMX we know the 1.3 into Q1 is induced load on the footing. This is the Q1. We are taking the maximum. We are not taking the Q2, because the Q2 is 1560, and on the other end Q1 equal to 2016. So Q1 is more, that's why we are taking the Q1, and found this. And now we will evaluate punching force equal to maximum force, and found depth, which is 0.85 meter or 2.77 feet. So, so let's see another example. The int column is along the perimeter line. This is the perimeter line connected to the interior column in rectangular footing in given below following data are given below. Column loads is q1 50 and q2 100 kip and size of the footing 1 feet by 1 feet. Size of the column 1 feet by 1 feet square. Yeah, a clear length of the between two columns is 9 feet and determine the dimension A, rectangular footing and net allowable variance 4. So all the data is given. We have to find out A and B. So this is the A as this is the rectangular beam. So now we'll first of all we'll calculate a summation of Fy equal to summation of Ry. So apply load equal to resisting force. So apply Q1 A1. So we know the Q1 and A1 equal to Ry equal to 152. So this will be reverse of 152. So now we'll calculate the how much XR. So XR equal to Q equal to A by C by 2. So this is the C by 2 as we are taking the CG of the column, and Q2 equal to CG by 2 plus LC. This is LC and Ry where get the Ry value 150 and XR this is the this distance is XR. We are calculating this and found XR equal to 6.5 meter. Now we will know the stress equal to force per area, and we are subtracting here, and we know area equal to force per stress, and found force equal to Q1 plus Q2 induce and found as 37.5 feet square. Now we're calculating again a rectangle for A equal to A into L. This is the A and L equal to this is L, and found L equal to C by 2 plus LC into C by 2. This is the C divided by 2 and this is the C divided by 2 and this is the L. And in this way we have found A equal to 3.75. So this is the 3.75 and LC L equals to 10 feet. We have already found this. So now we'll calculate this is the extra portion from how we'll get the thickness. So this is not our in lecture, but I will try to find out how we'll calculate the thickness area of perimeter. So this is the this is the column we are taking here. So we know C plus D. This portion is C plus D. This is the column. So this shaded portion are column, and C plus D. So this is the C, and this portion is D by 2 and into 2. Why you taking the 2? Because this portion and this portion, that's why you will multiply into 2. And the vertical portion we have C D by 2 plus C into D by 2 into D by 2 and into D, and found this equation. And we know the perimeter punching force 0.75 into 0.30 root over FMC AP is found the previous calculation and found this equation. Now we know the maximum max 1.7 into Q2. We are taking the Q2. Why? Because Q2 is more than Q1. Q1 is only 50 and Q2 is 100. That's why we're taking the Q2 and found 170. And now we'll combining perimeter into maximum, and you find the value of this equation, and max is taking the 170 and BP is taken from this equation, and found depth is 7.56 feet. So let's see another example. Design the size of the rectangular combined footing. Figure is below. This is the figure below is given there. This is the perimeter line, and the following data are given. Column load we have been shown the F1 is 100 kp, F2 is 20 feet, and F3 20 feet, and F4 100 feet. So we can see the F1 and F2 are the same load. On the other hand, we can see F2 and F3 are the same load. An allowable bearing 34 KSF is given. So all data is given. We have to find out the find out the value of A, as we have shown the all data is given in X direction, and this is the property line. So let's see a summation of Fy equal to summation of resisting induced force into resisting force. So induced force F1, F2, F3, F4. So this is the F1, F2, F3, F4 is given all data here, and Ry equal to 600. So 600 will be Ry. So now we'll calculate the distance of Rx. So we know f1 into c1, so f1 into c1 is given here. I'm changing color. This is the distance, and f2, this is the f2, and distance will be c1 plus 2 plus 6, c1 plus 2 into 6, and f3, this is the f3, so f3 portion will be from this point, from the left point to the the distance of the certain of f3 point, and found c2 plus 6 plus 6, this is the 6 and 6, and in this way we are calculating f4, this is the f4, and fy into x1, and putting all this value, and found x are equal to 9.834. This is this distance is we can call x r, which is 9.83. Now we will calculate a equal to force into stress, and found here, and area is 150. Now we are comparing here. We know the area of rectangular combined footing A equal to A into L. We know the A, and L is here L. We know the another is A equal to force into Q net, which is we have found 150. Totally we have found 150. On the other hand, we know the A into L. This is the L. How we will get C plus 2. C plus 2 6 6 8 2. So C plus 2 6 6 8 2, and found A equal to 6.63. So this is the 6.63, and L equal to 22.5. So 22.5 is we have already found in the question. So this is our answer. So now we'll calculate the extra. How we'll calculate the thickness of the this footing. So this is the extra information. So now we'll calculate the thickness of the footing. So this is the column. We are taking a shadow also. So AP, now we'll calculate the area of perimeter, which is C plus D by 2. So this is the C plus 2. So C is here, and D by 2, n into 2. Why you will calculate, why you multiply 2? Because this is the horizontal portion 1 and horizontal portion 2. On the n plus D by 2 and C plus D2. This is the vertical portion. We can see C D by 2, C plus D by 2, and multiply both are D, and found this equation. And we know the area of perimeter 0.75 0.30 root over f and c. AP is found from the previous calculation, and this is the equation we are taking here. And B max equal to 1.7 into F2, because we are taking the maximum load is 200, and found 30. Now we'll compare the B perimeter into B max. So B max is here 30, and B perimeter, this equation we are coming here, and D is found 12.62 feet. So we can see another example here, the design of the size of combined footing. We can see here the footing and the way loading the surface of geometry and boundary condition is provided. All the column are sectional dimension 1 feet by 1 feet. Use the allowable capacity 3. So these are the given here. So P1 is 100. This is the P1 100, P2 and P3, P2 and P3 is 70, and all the C1, C2 are 1 feet, and Q allowable 1.5 TSF or 3 KSF. So A and B, the dimension we have to calculate A and B. Okay. So we can see here the apply force equal to resisting force. All the apply load P1, P2, P3. Here is the P1, P2, P3, and Ry equal to 240. And we are taking the moment from here. So P1 plus C by 2, and P1 into C by 2, and P2. This is the P2. P2 and P3 are the same equation, same line. So P2 into 10. This is the 10, and minus C by 2, and P3 also same, and found the XR equal to 5.7 feet from left portion. So this is the XR. Now we'll calculate the area equal to force into stress, and found 80 cube feet square. Now we'll compare the trapezoidal area equal to force into stress, which is putting here. On the other hand, we can know the trapezoidal area A into B into divided by 2. This is A and this is B, and divided by 2 into L, and found the A plus B equal to 60, which is A equal to 16 minus B. This is the equation 1. Now we'll calculate the apply moment equal to resisting moment, which is A1 x1. So A1, this is the three portion. The first portion is here, the shaded portion. I'm erasing unnecessary portion. This is the first portion, which is shaded area, is A1. So A plus B, this is the A, and this is by 10. How will get 10? This is the given on questions. This is the L, which is 10. And x bar equal to 10 divided by 2. This is the portion of A1 x bar 1. So in the same way, A2, half into length into b by 2, half into length into b by 2, this portion. And A2 and A3 remain same, that's why you will multiply 3. And x bar equal to 2/3 into length, so 2/3 into length, so 2/3 into length. And in this way I found putting all this value and found b equal to 11.61. So we are multiplying, so deducting value of b and found a for 3.69. So a is 4.39 and b equal to 11.61. This is our equation. So now we'll see the extra portion, how we'll calculate the thickness. This is the AP, we know c plus d by 2 into 2 and d by 2 c plus d by 2 into d, and found this equation. And area punching force equal to 0.75.30 by FMC AP and found this equation. And maximum load is coming 1.7 into P1 and found 170. And now we'll compare this and found depth equal to 7.56 inches. Okay, this so I can say the first topic we have covered. Now we'll discuss the determine the pressure of the combined footing, combined and mat foundation. So let's see the plan of the mat foundation with column load and dimension is showing below. They calculate the soil pressure at point ABC. So you can see here, this is the our mat foundation. So 12 feet, 5 feet, 15 feet, 10 feet. And ABC portion is point A is here, point B is here, C is here, and D is here. And all the load is given. We can see here 370, 300, 700, and 500, 600, 500, 600, 500. And column dimension is different half inch, 1 inch, 1.5 inch, 2 inch, 1 inch, feet, 1 feet, 1 feet, 1.5 feet, 1 feet, 2 feet, this way. So we know the induced force equal to resisting force. Induced force A1 P1, P2, P3, P P7 equal to R. So if we calculate 300 and sorry, these are the P1, 3 and 600, this is 600, and 500, this is the 500, P3, P7, this is the P7, and 300 also, and 500, this is 500, and P8 is also P7 also 400. So R equal to will be total resisting force, which is 3370 kg. Now we will calculate the applied moment equal to resisting moment. So x direction. Okay, so this is the x direction. So A1, so 300, 700, 300. So this is this portion we can calculate now. This load, and all the load is this is peripheral, which is A by 2, 1 feet by 2. That's why 1 feet by 2. And now we'll check the second row, which is 500 and 600. So this is the row. It is coming from 12 feet. So this is the 12 feet. And third one we can see 5 and 40, 400, 5 and 400. It is 20 plus 5 plus 25 minus half. So in this way you will found XR, which is 20.36. And if we calculate the eccentricity B by 2 into XR and found 4.64 in the left side. In the same way we can calculate the in the Y direction. So Y direction we will calculate 300 into 1.5, 300 into 1.5, 5 divided by 2, 1.5 divided by 2, and 5 into 500 into 1 by 2. So this is the 500 and divided by 2. I am erasing previous So this is the second calculation 5. uh, this is the second calculation 5 into divided by into distance is 1 by 2, where this is the 1 by 2 and 400. So you can see here the 400. This is also 200 divided by 2. So where 204 divided 2 divided by 2, and 7 into 20. And in this way we'll calculating putting all these below and found yr, which is 25.5. And here we will calculate the eccentricity of y direction, which in this direction, and found 4.40 in upward. Okay, let's see. So we know b into h. B is all the given, we know 20, and all the equation we know, and 50 into 50, and the value will be 2500. Mx equal to r equal to ey, and found 1320 keep fit. And myy, so we have to keep mind, then while we calculate the myy direction, then we'll take the ex. When we calculate the x-axis, and we'll take the ey, and found 15315 cube feet. And ix equal to bh cube by 12, and iy equal to b cube by 12, and found 5 these below. Okay, now we'll calculate the stress in various direction. Now stress at a. So this is our what I will say, this is our I'm taking the picture. This is our picture. Now we'll calculate stress at a. This is the point of a. So now we calculate p by a into plus mx y ix plus myx iy, and putting all the value, while the value of y equal to 25 and x equal to 25, and putting 2.1 feet. Now we will stress at b. So this is the b, this is the b point, and p by a minus y will take the minus. So this is our coordinate. So x, if the x-axis first coordinate x plus x, and second coordinate plus x minus x plus minus plus y. So this is our second coordinate. So we can shade it here. These are the minus and plus. That's why we will minus and plus, and found 2 ksf. And c, now we'll calculate the stress c. This is the point of c, and we'll use plus and minus. Why? Because this is the this coordinate. So this is the shaded of coordinate. We'll use plus, first of plus, and second one is minus, and putting all these value, and found 0.905 ksf. And d is p by a into 0 into 0, because there is no x and y value. We can see here d is look at the cg, and found 1.32. Now if we calculate the thickness in this way, we equal to c plus d by 2 into c2 plus divided by 2, and found this equation. And force perimeter force 0.75 to 0.30 root over f, and found this equation, and b max equal to this equation. And we'll compare this equation, and found the depth, which is 39 inches. So these are the moment calculation of the mat foundation. So if you want to interest, you can take this, and found in this way you can calculate the moment. If you get the moment, and you can calculate the area of steel. So you can see another example, which is calculation of stress. You can see the plan of the mat foundation is shown in the figure below. Calculate the soil pressure at the point ABC. This is the ABC. This is the point is given ABC. This is the B, this is the C, this is the A. Okay, so this is A, and this is B, this is C. Under geometrical condition, eccentric of foundation of all the columns are 12 by 12 inches in the size. So let's see. We know the induced movement into resting movement, induced force into resting force, and P1, P2, P3 equal to resting, and found 250 kg. And now movement, induced movement equal to resting movements in x direction, or 1 y, and found this two value, which is 60 into 90, and this the distance is 2 feet and 2 feet, and another one is 100, and distance is from distance, which is 9 into 2, which is 11. And resisting, we know the 250, and RR is unknown, and 5 pound XR is a 5.6 feet from left. And we will calculate the EX, eccentricity, up into B into XR, and found 0.60. Okay, in this way, in the same way, we will calculate the MR in y direction, and 900 into 100. This is the 90 into 100, and the distance is 2. So distance in 2 and 60 into 9. I'm just taking okay. So we have found 60 into 9. So you can see here, here 60 into 9. Okay, this is the 60, and the distance between 9, 7 into 2, it will be 9. And found YR, which is 3.63 from bottom, and eccentricity Y equal to 130 H into YR, which is 0.32. Now we will calculate area, which is half into B into H, which is half into B into H, and found 50. And MXS is equal to R into EY, and while calculate MY, then it will be R into EX. So remember that IX equal to B is cubed by 36, as this is the triangle footing, and IY equal to B cube H into 36, and found this value. Okay, so let's see how we'll calculate the stress. This is the equation of stress, P by N to sigma xs y plus sigma xs and to this value. So we will calculate the value of y into x. So let's see y into x. This is the portion we can see. We have to go there. This is the CG. So we have to calculate from this distance. We are found 3.68 minus 2, which is 1.66, but we are taking the equivalent, which is 2 feet. And in the same way, we are calculating this value, which is 3.96. We have seen this is the y value. On the other hand, we can see the x value. We are found 2 into 9 minus 5.4, which is 5.4. We are taking 6. So this is the 2 and 6 value, and putting this value on found 3.8. In the same way, we will found B. So you can see the B. We know the P by 250 divided by 90, and we are taking the y 2.5 and x equal to 3.5. So we are know that this is the CG point. So the distance between this point, we are taking y, which is 3.68 minus 2 into minus 1 back divided, and found 2.18, which is similar to 2.5 feet. In the same way, we are calculating the distance of x, which is 5.6 minus 2 in plus half, and found 4.1 feet, which is the similar to 3.5 feet. So we're taking this value, and we know the coordinate, which is plus xs plus yy. That's why we are taking the minus here. In this way, we calculate FC, stress at C, and stress at CG, which is CG, and found 2.70. So let's see another example here. So plan of a mat is shown below figure below. Calculate the soil pressure at the point A, B, C, and geometry is centroid footing. All the column are given 12 by 2. So this is the given. So A, B, C is given here. So in this way, we will calculate the induced force P1, P2, P3. So this is the P1, P2, P3, and R1 equal resisting is 340 cube, and moment, induced moment equal to resisting moment in x direction, 100 into 100 into 4 y. This is the because we are taking this only two load, first of this load and this load, and it is situated distance of x. This is the x distance, and 140 into 140 into 12. This is the another load, 140 into 12, 4 into 4 into 4, and found into 12, and found 340 into x bar and found x bar equal to 7.29 feet, and the eccentricity ex equal to d by 2 into x r, which is 1.70, and the resisting we can see the resisting induced force equal to resisting force in y direction. In the same way, we will calculate 100 into 140. So this is the 100 into 140, and distance will be 4. So this is 4, and 100 into 12. So you can see this value 100 into 12. I will get the 12, 4, 4, 4. Then found 12, and in this way we are putting this value and found y direction 6.35, and the eccentricity will be 1.665 feet, and from CG. Where now we will calculate the area pi d square by 4, and the mxx, and we will take the mx, and we will put in the ey and calculate the my, then we will put in the ex, and as we know, this is the circle, that's why we will calculate pi t to the power 4 by 64. In this way we will use the moment of inertia. Now we will calculate the stress at A, P and C. So we know the P by M minus A axis into Y into X. I will get the value of Y into X. In this point we can see this is our CG. From CG to here is, we know, the 4 feet, and this if we detect the half inches and found 3.5, but we can see here the use they have used 3 instead of 3.5. So this is a confusing. So if you calculate here, then you can use 3.5 instead of 3. Okay, so let's see here another example. It is stress at the point of B. Okay. Let's see the example of stress B here. The same equation we have used, P by A into minus xx into y into plus xx into y, and found in this way 2.62, and the value of distance of y in x is found 4 into 4. I will get. So let's see, this is the CG, as we know here the CG. We will calculate the stress at B point. This is the B point. So we know the distance of x is 4, and distance of y is here is 4. That's why we are using 4 into 4, and found 2.69. Okay. Maybe this is our last what I will say. This is our last math. So let's see. The plan of the mat foundation is shown in the figure below. Calculate the soil pressure AB, and where is the B at the geometric centroid of foundation. All the columns are 15 by 50 inches in sizes. So you can see here this is the A, B, C, D, E, and all the dimension is given. So P1, P2, P3, we know the induced moment equal to resistance moment P1, P2, P3, and P5. So P1 is given 250. This is the wall load. 250, 100 into 100. So this is the 250. This is 100. This is 100. And 150. This is the 150, and 100 into 100. This is the 100 into 100. Okay, and found the resisting force 800. So now we'll apply moment equal to resisting moment in x direction. This is the x direction we will taking. So I'm taking okay. So x direction 100 into 100 plus 100 into 2. So at first we are taking this 100 into 100 into 2, x bar equal to 2. We can see here, and we can see another 100 into 100 into 9. So if we okay, this is the 100 into 100 into 9. You can see here the second one is 100 into 100 y in the y direction, and 100 into 100. So I'm sorry. So 100 into 100 into y direction, 100 into 100 into 9. So 7 into 9. So this is the y direction, and first case was 1 plus 100 plus 15 plus 100 into 2. So this is the first load and direction. Oh, sorry, this is why I'm escaping x. So x-axis is at first I am taking 100, 100 into 100. So this is the 100 into 100 into distance x, and 150 into 250 into distance is x. So 150 into 250 distance is x equal to 13 into 2 into which is 15, and 100 into 100 which is taken 22. How will get? So 13 into 13 plus 7 which is 20, and plus 2, so it is the 22. So this load and distance is x. Okay, and in this way we will calculate the y direction, which is found. I have earlier said, but I am saying again, 100 plus 50 plus 2 into 2. So this is the first row of the load we are found here. I am saying the another load 100 and 150, and the distance of here is 2. Okay, so 100 into 100 into 9. This is the second load, 100 into 100, and found 9. How will get the 9? The 7 plus 2 is a 9, and 250 into 16. So 250 is a distance of 16, and found the y are equal to 8.21 feet, and eccentricity y is also found. Area we know, calculating the 2 area, 14 into 9. So this we are taking the 2 area. This is 2 area. The shaded portion is segment 1, and another is this segment. So this segment and plus this segment, and found this area. Mx, when we will get x, we will multiply with y. When we take the y, then we will multiply into x, and Ix is equal to 24. This is the segment 1 for rectangle, and this is the triangle, and this is also triangle. So there are 3 type of triangles. So if we take the measure here, so we will take, this is the portion and this is the portion. So at first we are taking this shaded portion is 1, and this zone is taking another, and this portion is another. So that's why while taking the rectangle and the trapezoidal and found in this way we will found x-axis, and the y will found the y-axis also. Now we calculate the stress at C. This is the sea level. So if you calculate P by into x into y, so x equal to 10, how will get? 2 plus 2 plus 2 plus 2 into minus 10, and found this level. And y equal to, we have found 2 plus 13 into minus 7 equal to 3. So found here, and found 10.5 to KSF. On the other hand, we can use 0, x is 0, and y is 0, x equal to 12, and found 1.21. So this lecture is in depth. If you have any question, then let me know for purposes. This lecture is mainly focused on depth, how we'll calculate, how we'll find the footing length and breadth. But in the second term, we have used, at the first time we have used the determine the size and thickness, and second one determine the pressure. So if you have any question, then let me know. I will try to answer all the questions. Thank you everyone. If you have any question, then let me know.